Hey friends, welcome to the channel. My name is Jay Wilson. Today, if you can't guess from the screen, we are going to be talking a bit about forecasting. Now, forecasting actually is built into Analyzer into a handful of the different chart types. You might look for multi-period projection, you might look for regression line or last value projection. All very powerful tools that try to help you predict the future. Now, for me personally, when people start approaching me with questions about forecasting, one, I raise up my hands and I'm like, guys, I'm not a data scientist. I'm not a mathematician. If you want real guidance on how to do good forecasting, go to talk to one of them. That said, what we are going to talk today is about how to build forecasting into a data set. Because I think that's the biggest shortcoming or thing I would be concerned about if someone was building forecasting using Analyzer, is that these numbers here, this 31,000 number, does not exist in a data set someplace. So I have no way of figuring out, is Domo actually any good at forecasting? Let's take a step back, though, and take a look at some core concepts when it comes to forecasting. If I could find my notes. All right, here we go. So some basic forecasting stuff. The whole point behind forecasting is to answer this basic question: what will we do in the future? Can you create a new row in my data set and just predict the future? That's question number one. Question number two is, how good are we at predicting the future? Again, I'm not a data scientist, so I'm not super smart when it comes to like, okay, you should use the lasso method to forecast the future or categorize your data. That's not my bag. What I can tell you is some ways to structure your data sets so that you can swap in and out different forecasting methods and assess how good each method is at predicting the future. But before we get to that, just a really critical concept. When you're forecasting, your data has to be structured so that one row represents one unit of analysis. Think about it. When you're forecasting, whatever algorithm you're applying, it's applying crazy math onto that one row or maybe a set of rows in your data set. It's going to generate a new row that predicts the outcome, right? But the critical thing is that the input must be at the same granularity as the output. And this blew my mind, right? Because when I do Domo consulting, I always tell people, look, guys, don't aggregate your data in an ETL. Let Analyzer handle that. But in order for data science to work, one row must represent the granularity of the output that we're looking for. That sounds pretty vague, so let's get into a data set and really see what we're talking about here. Let me close out of this guy. So here's my raw forecast data. This is a Kaggle data set. I'll link where I got it below so I can cite my sources and all that. But look at it. It's got the column date, store, item, and sales. If I sort by date descending, I can see I have multiple rows for my last day of data, December 31st. I have one row per store, per day, per item, and the number of units sold. So this is already aggregated at the item level. But if my question is, hey, yesterday across all of my stores and all of my items, I sold 2,000 units, what am I going to sell tomorrow? The input data set is not at the correct granularity yet. The input data set needs to be at the granularity of one row per day, total sales, and then I can predict total sales tomorrow. Eventually, I'm going to show you how to predict date and store, but we'll call that an advanced concept. We'll get there in a second. That's why I have 4 different data flows that we're going to run you through. All right. So I start with my forecast data. First thing I'm going to do is get the data into the right unit of analysis. I'll apply my group by clause and say I have one row per date, and I want my outcome to be the total sales. And then while this preview is rendering, let's just take a look at this forecasting tile. This forecasting tile comes from the Data Science Toolkit, one of the many. I know you guys are probably wondering, Jay, should I use it? Do you endorse it or not? Whatever. I have a whole other video that I'll link in the description below where Doc Stevens and I talk about the Data Science Toolkit and my feelings there. That's an older video. Some of my opinions have changed since the release of the Jupyter Notebooks into GA. Another conversation for another day. Let's just talk about this pipeline. I have here the forecasting tile. I'm saying, hey, I want to forecast based on the column called date. I want to predict the total sales column. I want to have this 95% prediction bands. Generally what that means is it means, as I understand it, again, not a data scientist, it means if I predict this value, whatever this 95% is, I'm 95% confident my value will be within this range, 90 plus or minus, whatever the actual guess is. Yeah. So when I'm conducting my forecasting, how many days into the future do I want to predict? 7 days. How many rows of data do I want to consider when I'm coming up with my forecast? I'm choosing 90. And then what are my upper and lower bounds? Again, what am I 95% confident, and I'm pretty sure I'm wording this correctly, but probably not. I'm 95% confident that I will be within this upper and lower value. Here, if my observations are occurring, if my data is coming in at the week level or the month level, and I'm, I have 1 row per day or whatever, then I might change the number of times each row is observed per time period. Again, if your data is aggregated at the date level, you should be able to leave this alone. Cool. Let's just take a preview of my data looks like. After my group by clause, 1 row per date, sum of total sales, pretty straightforward. When I apply the forecasting, I'm not going to immediately start with the bashing, but it was a design decision that as I apply forecasting, I include all of my actuals rows, all of the rows of actuals that I have, and then way down at the bottom of the data set, which we can't see here, I'll see my predictions. So what does that look like? In my basic output, right, I think I said predicts 14 days into the future, so if I sort by date descending, my last day of actuals data is December 31st. Again, the granularity has been set at 1 row per day. I now generate, I lied 7 days into the future, and these are the values that I'm predicting. And I'm 95% confident that I will be between 34,000 and 15,000, but my actual guess is like 25. Okay. I'm giving a really terrible description of these upper and lower bands, but if you want to think about, okay, Jay, well, why would you say you're guessing 25, but you've got 34 and 15,000 as kind of like these ranges in between? Well, what if it's really expensive to have less than enough stuff? Like, what if it costs you $10,000 a day for each unit that you don't have on hand? So like you guessed 25, you actually ended up needing 27, you're 2 units short, that's a $20,000 fee, which for some of us is not a lot of money, I get it, right? And what if the cost of retaining inventory, like the cost of having too much stuff, is like $5? Here, sorry, let me put this in Excel so we can see this. So I guessed 25. My actual need was 27, which means I was short 2 units. And my cost for being short is $10,000, or let's say the fine. And my storage costs for everything I carry too much of, let's say, is $10. Okay, so if we're building a cost equation, right, this is why this 95 percentile matters. My 95% upper band was 35. Okay, so like what we're trying to discuss here is what is the cost of being wrong. So I guessed 25. My actual need was 27. How much cost did I incur? I incurred 2 times 10,000. Oh man, if only I could do cell references. 2 times 10,000. My cost for being wrong was $25,000 or $20,000. Let's say I was like, okay, guys, let's err on the side of caution. Let's stock 35 units instead of our forecast of 35. So then what is my cost equation? Well, I guessed 35. I consumed 27. So that means I had 8 units left over, which I had to put into storage, which costs me $10. So it costs me $235 to be conservative and be 95% confident that I'm going to cover all of my stuff, as opposed to me being like, nope, I'm just going to have 25 because that's what I guessed I would need. And I got 27. Now my cost is a $20,000 fee. That was a little bit of a diversion, but that's what kind of the purpose of these prediction upper and lower prediction bands are. They're used in like a cost equation to say, okay, I know what my prediction is, but if I'm wrong, how much is that going to cost me? Assuming you're tying forecasting back to costs, right? Like I could have 20 gallons of ice cream or I could have 35 gallons of ice cream. How upset are my customers going to be if I run out of vanilla? What is that cost equation? Anyway, back to forecasting. Let me come back to my notes. We talked about this idea of a unit of analysis, where we are applying crazy math to a data set to predict the next row of data. Now, you might look at this prediction and you might say, okay, I want to use a rolling 30-day average. I want to use some sort of a half-life equation, magic stuff. Whatever your model is, I frankly don't care. We're just using whatever Domo's prediction forecasting tool gives us to say that that's the right number. But you could literally swap in any kind of forecasting method right here. Cool. The next thing we need to take a look, though, at is, how good are we at predicting the future? Jay Wilson, you guessed 25,000, 26,000, da-da-da. Where's your accountability? How do I know that you're good at predicting the future? So we need to extend our model. That's what this data flow is going to give us here. The high line is, I'm going to say, hey, why don't I take a look at what I predicted at 12/24 for the next 7 days? Let me cut off my data at 12/24, and let me use Domo to forecast 25th, 26th, 27th, 28th, 29th. And let me join in what actually happened. And now I have accountability. Jay, you guessed this number. This is what actually happened, and here's your error. Okay, so how are we handling this? We still have our group by, right? But what I want to do is I want to set my forecast date as a slice in time, so 12/24. I'm going to offset 7 days. Go back 7 days. Filter out anything that is before the 24th. Sorry, any data that comes after the 24th. I run my forecast. Same parameters, 95 percentile. I'm going to predict, I lied, 14 days into the future. I'm going to consider the previous 90 days worth of data as I'm constructing my forecast. But all of that data is before the 24th, right? Because that's my cutoff. Then I'll construct my forecast. Here, what I'm choosing to do is I'm only going to keep rows that are prediction rows. So what do I end up with? Here's my 25th, 26th, 27th, 28th, 29th, 30. and that's my predicted value. Interesting me that all of these numbers are the same except for the 25th, but that's just the model. We're taking it, we're running with it. We're not asking questions about the predicted value. We don't care. If you want to use some other method model, go ahead, but the data pipeline or the process should be the same. The process says join in what actually happened and calculate the error. So on the 26, 27, 28, I join in my actuals, 87. This is what actually happened, and this is what I predicted. Okay, so I predicted 87. I actually got 100. My upper boundary was 145. My lower boundary was 56. I'm well within the 95 percentile range. How good a prediction is that? Well, that's where the error comes in. I say, hey, that's what actually happened. I know what I predicted. My absolute error, we're not going to have negative error. We're just going to say my absolute error because we assume that 13 positive or 13 minus are equally expensive if I'm using absolute error. And I just do the math, absolute error. Now, as we discussed, your error model might have a fine and a cost associated with being plus or minus. You might have a different way of assessing how bad is, and you would just build that error calculation into this step that we're doing here. Okay. Now I'm choosing to union. These are my forecast rows, this stream down here. This upper stream is my actuals, and I'm unioning them into the output. You could probably get away with a join, but you know me, I love to union instead of join data when possible. Why am I doing that? I'm doing that because I want to be able to put into a data set, hey, here's my actuals, and there are my prediction rows. It looks like I'm double counting actuals. Am I a fool? Oh, I totally am. I'm double counting. Oh, no, I'm not. Yes, I am. I need to remove actuals from my forecast row. Whoops. I'm going to drop the actuals column so I don't double count. Okay. Either way, it's all fine. Okay. So again, the goal of the output data set, let's take a look. Forecast with error. I'm going to sort by date descending. Let's focus on this section here. So this pair of rows, this row should represent the prediction row. This row represents the actuals row, and I just should not have included the actuals in my prediction row. Usually I would add a column like activity type to indicate that this set of data refers to the actuals and that set of data refers to the prediction. Okay. We're doing well. We're doing well. I know this is a pretty long explanation, but I don't think the process of like coming up with a forecast is not hard. It's how do I represent that in Domo in a way that I can then put it in a card or use it or explain it to someone. We talked about the unit of analysis. Let's move on to this idea of categorical versus numerical data, because this is another place that people really get screwed up when they're doing forecasting. When you're handling forecasting in general, unless you have a more sophisticated model, it has no concept of a category. Data models are really great with numbers, but categories are where things kind of get weird. If you think about forecasting, right? In my initial data set, I had two dates. I had two columns. I had dates and I had the amount. Now the dates column could be reduced to a number. The first day, the second day, the third day, the fourth day. All categorical data in your model will get reduced to a number. Objectively, that's true. You might sell a game, you might sell a cookie, you might sell cereal, but your data model will turn it into a number: 1, 2, 3, 4, 5. The only question after it reduces your categorical data into a number is if the data is ordered or not. So a date is obviously ordered. The first day, the second day, the third day, the fourth day, those dates are ordered. But cereal, what's another product category? Game, TV, mop, right? Those are categories that we're going to reduce to a number: 1, 2, 3, 4, 5, but they're not ordered in any kind of way. One is not better than the other. Some categorical data is ordered. If you think about a Glint survey or customer satisfaction, right? We say, hey, on a scale of 1 to 10, how satisfied were you? A 1 is significantly worse than a 5, unless you're from Germany and your school system is backwards, but different conversation. I went to school in Germany, it's fine. But the point being that categorical data will be ordered or not, and some data models will work nicely with them, many won't. There's also this question of whether or not a column should be discrete or not. Discrete data means it's a bucket. Like on your survey, you either get a 1, 2, 3, 4, or 5. You don't get a 1.276. Same thing with the number of units sold. Typically, we expect that data to be discretized. Discrete. I sell 1 unit, 5 unit, 12 units. Think about age categories. You're between 1 and 18 and 20. What comes after 18? 19. 19 to 27, right? Those become numerical categories: 1, 2, 3, 4, 5. They are ordered and they are discrete because we're not looking at your individual age in a survey. Okay, moving on. Some data types have a scale. Celsius, between, when I'm talking about temperature, typically I expect to see data between, I don't know, negative 50 and 1,000, or kelvins, or whatever your scale is, right? When you're dealing with scaled data, or data that exists on a scale, it's kind of interesting to say, well, how do I compare temperature in the same data set as the number of units sold, and in the same data set as, the dimensions of a box? Do I need to scale my data so all of my data is represented on a scale between 0 and 100? Do I represent all my data so it's on a scale between -1 and +1? I don't know. But these are things we have to think about and hopefully Google before I try to get into forecasting, because different models expect the data to be scaled or set up a certain way. Okay, that was a long explanation about why categorical data is tough in your data sets, but let's talk about how it actually applies for us. If I go back to my original data set, you'll recall the original data set was a forecast by date, store, and item. Even if I just wanted to see performance by store and ignore the item, my group by clause would be date and store. Let's actually go into my ETL where I've done that already. Right. So here, I've done my group by clause. I want one row per date and store. I can see that on the 17th in store 2, I expect to have a total sale of 45. I can't just pass this into my forecast tile, because my forecast tile expects one row per date. And frankly, store 1 might be like a Walmart sized store, and store 2 might be a mom and pop sized store. And I can't apply the same assumptions that I apply to a Walmart sized store that I apply to a much smaller mom and pop store. In a nutshell, what I have to end up doing is I have to create one forecast, one model for each type of store. Or sorry, for each store. Store 1, store 2, I think I have 10 different stores. This is the part where I think, there could have been some thought placed to how Domo designed these forecasting tiles, because, right, I want to generate one forecast per store. I don't want to have to generate 1,000, copies of these rows. Here in this formula tile, I'm setting the value of store to 1, or I'm setting the value of store to 2. because when I generate a forecast, it doesn't apply labels. Try it, you'll see what I mean when you do the thing. All right, so now I have two sets of filter rows. Two sets of forecasts. I'm doing an append, and I'll output the data set. You'll notice here I haven't done the join in back to actuals so I can measure how good my forecast was. I'm just doing this in small chunks so you can see it. This is how I generate one forecast per category. Let me stress the word category, not store, because if I wanted to do one forecast per item, right, I would have to go through the process, generate this set of tiles per item. All right, so what does that look like in my output? Again, I'm not joining on to the actuals, but here I can see, hey, I've generated a forecast for store 1. I've generated a forecast for store 2. They are different models. They have different upper and lower prediction bands because I expect these stores to behave in a different way. Okay. Now it starts to get messy. The last one? This is the last one. Okay. It looks ugly, but now I'm joining it all together. Ha, ha, ha. What I'm doing is I'm still grouping by date and store, right? So I still have to say, hey, I want to have a forecast for store 1. I want to have a forecast for store 2. We understand that. We literally just talked about that. What I also want to build into this pipeline is I want to build in accountability. So I want to say, hey, can I take a look at, I'm using a forecast offset of 0, which will return this forecast on this date today. But I also want to capture, hey, what was my forecast 7 days ago? And if you'll recall, if I set my forecast date to 12/24, I can limit my data to just up to the 24th, and I can forecast 7 or 14 days into the future. But hey, I also want to capture my forecast 14 days ago, and I want to capture my forecast as it stood 21 days ago. I can count. Okay, so now I have 1, 2, 3 different forecasts. What's going to be interesting to see is, hey, as I got closer and closer to today's date, did my forecast get closer and closer to the actual value? Hopefully the answer is yes, but okay, how do I see that? Well, I'm taking all of my different forecasts, forecast today, forecast 7 days ago, 14 days ago, 21 days ago for store 1 and store 2. That's why I've got so many sets of data that I'm appending or unioning. Okay, I get to here where I just keep my predictions. All right, so on 12/11, so sorry, let me start over. On 12/10, that's the date I took my forecast. I predicted that on the 11th, I would sell 29 units. That's what I predicted on the 10th. On the 24th, I predicted I would have 23 units. So my prediction got a little bit more conservative. How did I do? Did I go in the right direction? So what I do is I join in my actuals like we've discussed before. So now I can see. On the 17th, for store 1, I predicted that on the 28th, I would have 17 units. 1 week later, I tightened up my prediction to 15. How did I actually do? 19. Ooh, I went in the wrong direction. My error, do I calculate error? Hopefully the next column. My error. Ooh, I'm still not using absolute error, but I can see here I'm tracking my absolute error to the prediction, and I didn't actually wrap it in absolute, which is why that number is negative. Sorry. Cool. So now I can say, here was my prediction on this date. Was I good or bad? Another thing that might be interesting might be to say, hey, did your prediction change from the previous time I had a prediction, from my previous prediction? So maybe I'll add a window function where I do a lag of the previous prediction. So sort by date ascending, partition by when I took my forecast or when I made my prediction, and the store. And then now that I have my lag or my previous prediction value, let's see here. So let's see. On 17/12, I predicted 21/8 for 12/12. So on the 10th, I predicted 2 days later, I would sell 21 units. I actually sold 13. Ooh, that's a pretty big gap. So my absolute error was 8, which is like almost 50% off. But my previous prediction was 21.8. So actually going from 21.8 down to, oh, they're both 21.8. I didn't actually have a variance in my prediction. Shame on me. Point is, you can see that I'm adding in some metrics to say how good am I at predicting the future and how much does my prediction change from one day to the next, right? It's super easy to predict tomorrow from this point right now, but if it was the start of the year and I'm trying to predict October 4th and I'm good, that's actually a pretty powerful forecast. Okay. Let's save out of this. Let's go to our final data set here so we can just see what it looks like. Kudos to you if you're sticking with me. This forecast is in the Domo Dojo ETL, so you're more than welcome to come in, take a look, and all the things. Ask me questions about it. Happy to talk to you guys on Slack and kind of get you sorted out. Why am I opening up the ETL? Sorry. We're supposed to be looking at the data set. Okay, so what is the final form, right? The forecast date is the label. So let's actually do a date. Let's pick a date in time. So I'm going to include one of my last days. Do 2018 26. Okay. And then let's include one store. All right. So for December 26, I actually had 2 different forecasts and then what actually happened. On the 17th, I thought I would have this number. It actually ended up being that number. As I got 7 days closer, I got a lot closer. But again, the further we're forecasting into the future, the greater my offset, the bigger the chances are of being wrong. What's intriguing to me is to see, hey, was I within my 95% bound? 986 to 3,200. Yeah, okay. So even 14 days ago, I was well within that 95% error rate. So like if I were, again, stocking 3,500 units, I'd be golden. And then 7 days later, if I'm like, ooh, I think I've tightened up my prediction, I'm going to move 1,000 extra stock to another store that maybe needs it, right? That's what this whole forecasting conversation is about. Oof. Thank you for sticking with me. Let's wrap it up in a bow. The first data flow, all it did was just give me a forecast, and that was kind of good. One of the things I mentioned is you can choose whatever model you want, coded in Python, whatever. The important part is the accountability. How good are we at predicting the future? And that's where we looked at this pipeline that accumulates the history of my forecasts in one data set so that I can say, yeah, I'm good or I'm terrible. I'm within my 90% bounds or I'm totally out. Some key learnings were that the granularity of your input must be at the same granularity as your output. So if I want to have 1 row per store, my data needs to be 1 row per store. If I want to have 1 row per day, my data needs to be aggregated to 1 row per day. We went through this idea that a lot of data models do not handle the concept of categories. Instead, categories get converted and reduced down into numbers. So if I have multiple stores, I actually need to have multiple separate models or multiple separate forecast tiles. And that's why we're seeing a bunch of tiles that look the same. I think the opportunity for Domo to improve this process is to have a model management tool, which arguably is what AutoML is supposed to accomplish, but I want it in Magic because that's where a lot of us are doing our work. I would love Domo to have some sort of a loop function so I could say, hey, I want to capture this forecast 7, 14, and 24 days ago. And if I change the parameters of my forecast, I don't have to update 26 individual tiles. That was painful. That's it in a nutshell. Again, my name's Jay Wilson. You can find my work here in Domo Dojo. You can shoot me an email or reach out to me on Slack. Hope this is helpful for you guys, and I'll catch you later.